all the bubbles supposed to go up?
Yep.
Okay.
Alright guys, welcome back. Chelsea here.
Evelyn.
Evelyn there. Today we are going to make a homemade lava lamp. So I told you guys in the last video the things that you're going to need are an empty water bottle, Gatorade bottle, or a baby food jar. You're going to need vegetable oil. You're going to need water. You're going to need food coloring. And you're going to need an Alka-seltzer tablet, okay? Alright. So, Miss Evelyn, here is your jar to make yours. So what we're going to do is we're going to do a 3-to-1 ratio. So we want 3 parts vegetable oil, 1 part water. So I'm going to fill my jar. If I have a jar this big, I'm filling it to here with vegetable oil, then from here to here with water. Vegetable oil first, then food coloring, then water. So vegetable oil. Go ahead and hold out your jar for me, ma'am. Thank you. Vegetable oil. Now, Evelyn, what was the next step? Nope. We got to do a color first. So I chose blue because today's video, as usual, is brought to you by Climb Zone. And Climb Zone's colors are blue and orange.
Pink.
Pink? This pink or this pink? This is the dark pink. This is the light pink. Dark pink.
Pink-a-dink.
Pink-a-dink. So, you can choose how many drops to do. I like to do 4. Just because I think it's a good number. But you could do 5 or 6. Doesn't matter. It's not going to hurt. So, if you notice, when we put them in, they're like little balls on the bottom of the jar. They don't really spread apart. Okay? And that's what we want. That's why we put the food coloring in before the water. Now, Evelyn, I'm going to fill your jar to the top with water. So let's bring it down here so everyone can see. So here's mine. It's all bubbled up now. Here's Evelyn's. So we're just going to fill it the rest of the way with the water. Then we're going to take 1 Alka-seltzer tablet. So these ones are the original name brand. They're from Bear. There's 2 in a pack. I'm using 1. I used 1 whole one on my lava lamp. This is 1 whole one on Evelyn's lava lamp. Hold that for me. Let me bring the camera closer. Alright, Evelyn, drop it on in.
Boing.
So at first it doesn't seem like it's going to do anything. And then what happens?
It starts bubbling.
It starts bubbling. And all the pink right now is where, Ev?
At the bottom.
At the very bottom. But as it bubbles, what happens?
It's going to the top.
It's going to the top.
It's like pink and it's like kind of throwing up, but it's going up. And it's not. And it's pink though. And it's not actually throwing up. I just said it's like it.
Alright, so you want to know the science behind that? Yeah?
Ow.
Let me find my little script here. Okay, so the lava lamp works because of 2 different scientific principles. Do you know which 2?
George Washington?
No, that's not a scientific principle. Density. Do you know what density is?
No.
Okay, that's how heavy something is. Alright, and then it's how compact a substance is, how much of it fits in a certain amount of space. Alright? And polarity. Polarity prevents the oil and water from mixing together, just like magnets. Some of them stick together real good, and some of them refuse to stick together. That's because they have different polarities. Okay? So water molecules are polar because they have a lopsided electrical charge that attracts other atoms. The end of the molecule with 2 hydrogen atoms is positively charged. The other end with the oxygen is negatively charged. Just like a magnet with north and south poles, The positive end of the water molecule connects with the negative end of other molecules. Oil molecules, however, don't have polarity. They don't have positive or negative charge, so they're not attracted to the water molecules at all. And that's why the oil doesn't mix with the water. That's the bubbles. Real lava lamps use a polar and nonpolar liquid just like our homemade one did. In a real one, however, the densities of the liquids are much closer together than vegetable oil and water. The denser liquid sinks to the bottom, but the lava lamp heats up until it expands and becomes less dense, causing it to rise upward. Instead of using our light, in our homemade lava lamp, we use Alka-seltzer to power the reaction. It reacts with the water to produce carbon dioxide gas bubbles. Those stick to the water droplets. See it? And then the water-gas combo is less dense than the oil, so they rise up to the top. At the top, the gas bubbles pop and sink back down into the air, allowing the dense water, or allowing it to sink back down to the bottom again. All right? We don't use heat in our lava lamps because it's a little trickier and it can use more hazardous materials. But this is very safe because it's all kitchen utensils. And after about 3 minutes, your reaction kind of slows down. But if Evelyn and I take a new tablet, we could start the reaction all over again. You can hear it.
Yeah, like soda bubbles. Except it's not. Just saying it.
So at the top, this is why we don't fill it too high. It does foam up at the top a little. All right, so those are our lava lamps for today. Super easy to do, super quick, and the science behind it is super cool. The next thing, and we can recreate it anytime, so Ev can take that with her home and show Mom. All right, hold on, I need a drink break before we go over materials for our next video. Whew. All right. Oh, we forgot our book. So, sun catcher goes on this page. So that's S-U-N. Here you go, Ev. Sun catcher goes on this page. Right in the middle. Next to your rainwater cycle in a bag. So, it's called Sun Catchers. Spelled S-U-N. S-U-N. C-A-T. S-U-N-C-A-T. C. A. T. C. H. E. R. S. Then you can turn the page, so your sun catcher with your water in a bag, turn another page. We're going to do, ooh, you probably saw that. We're going to do lava lamps next, so that's what we just did. So we're going to write that, L-A-M, or L-A-V, L-A-V, A, and then the next word is lamps, L, so L-A-V-A. The next word is lamp. So L-A-M-P-S. 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 Okay. The next thing you'll need for the next video is balloon rockets. So, we're going to need a balloon. We're going to need, you guys, I don't know, can you guess it? Can you guess it? your fancy toilet paper rolls or paper towel, whatever you can recycle. So we're going to take these from our pom-pom drop.
Mm-hmm.
All right. So, a tube from your paper towels or toilet paper. String, which we'll have to find. And where is it? Balloons. Okay? Sound good, Ev?
Mm-hmm.
Did you have fun today?
Mm-hmm.
What was your favorite part? Favorite experiment so far? They're all written in your book. What was your favorite? Pom-pom drop, fingerprint animals, rainwater in a bag,
of them.
sun catchers, lava lamps.
All that.
All of them. All right, well, we're going to do one or two more. So wave bye. We'll see you guys in the next video.